By the way, if some of you are thinking on the side, I'm going to go ahead. All right. All right, start off. If I give you y equals sine theta plus 4, what do I want? Fleming! What would I expect that plus 4 to do to me? Up 4, right? In fact, if you think about it, this graph is going to give you a number. What are you going to do that number every time? Add 4. So the whole graph's going to go up 4. So a number hanging off the back is shift up or down, right? That's all it does. That's a good one. We like that one. Give me lots of those. Here comes the bad news. Okay? What would I expect to have happen if I go y equals sine theta plus pi over 2? What would I expect to happen there? Left, right? Opposite way you expect, so left. Love it. How far would you go? Pi over 2. Beautiful. That's the correct answer. I'm going to muck it up in just a second, but that's the right answer. So what you would do is you would go, so my sine graph looks like this. Whee! And so instead of starting here, I would go to left, pi over 2, and I'd start my graph here, and I'd go like this, right? Okay? So that's what it would do, and that's legit. It's good. It's solid. It's great. Everybody so far? He's got his hand up, and I don't know why. I'm afraid to ask. He's got 8 minutes left. Should I trust him to ask a good question right now? It's going to help us go forward? Yeah. Larson!
Is there a difference between negative or minus 2 pi and plus? Because when they both end up the same. Or sorry, it'd have to be a 2. Okay, I'll just ask it. It's not
2 pi is going to be over here, right?
If you shifted enough, it just end up being the same.
It would, yes. If I shifted 2 pi, that's a big waste of time.
Well, no, shit.
Or negative 2 pi. Either one. Big waste of time. You're in the same spot where you started. Totally true. Now, there is a small glitch. And it has to do with the fact that this is one wavelength, right? This is one period. But the phase shift shifts where you are in the period. So I'm like, well, we all did this just fine, so why are you making a big deal of this? What happens if I change the period? So for example, if I put a 2 here, it's going to go through a cycle twice as fast. Which means this has half as much effect, so it should be a shift of 1/4 instead. Ooh. Now the good news for you is there's a formula for it. Okay? The phase shift formula looks like this. Phase shift is equal to negative C over K. Okay, I'm going to explain in a moment. Write that down. Negative C over K. This number right here is my C, right? So that's how much we normally shift left or right if the world was a just world. That's it, right? That's how we shift left or right. The K is the same K we ran into before. It's going to be the number we find right in front of that theta. And so if I put a 2 there, I'm going to divide by 2, making my phase shift half as big because my graph is half as big. So I need half as much bang for my buck. Okay? Why negative? And this is actually, I've taught it years where I've not done this negative. There's times I didn't teach it with a negative. And this year I'm going back to negative because SAT tests started putting negatives back on there. What? Why? That's the opposite of the way you expect. And this is what makes me nervous. Okay? If I put a minus sign there, I'm already putting the opposite of the way you expect. Right? So when we did your problem, it would tell you negative pi over 2. So don't do a double negative and go back the other way. Okay? The negative's there to say opposite of the way you expect. It takes care of that for you. Okay? Now I'm going to get that wrong this year because I'm transferring back from about 5 years of doing it the other way. Okay? So I'm going to try my best not to make a mistake here. But we're going to put the minus back in there because, again, that's what SAT test decided to do now. So we're going to go back to doing it their way. Okay? Good so far? Okay. So let's try y equals sine 4 theta. Ooh, that's terrible. Plus pi. Whatever. We'll do their graph. Okay? I'm going to run out of time, so I can't have time to think about it too hard. What just happened? Oh, I just erased it. No, undo that. I want this. Thank you. You got to talk to the computers, otherwise they don't do things. You don't think that's true? All right. Let me get ready to graph this. Same drill as before. I look at this and go, all right, well, I can do this. So I'm going bang, 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 bang. What's my parent graph? Fellows.
Starts at 1.
Okay, whoa.
Sorry.
That's the wrong answer to that. Y equals sine theta is what I'm looking for, right? That's my parent graph. And it's by the way, it's going to start at 0. That's where sine starts. Okay, moving forward. Okay, the 4, what did the 4 tell me to do? Period equals 2 pi over 4, which is going to be pi over 2. So my period is going to be pi over 2. Okay, now I'm going to get my next thing. I need another color. Let's try something exotic. Oh, I did great. Let's do red. Okay, then what does this tell me to do? I got a phase shift now, right? So my phase shift is going to be negative C over K. Okay? All right, now let's do our normal routine here. I'm going to go ahead and make this 1, 2, 3, 4. This is pi. 1, 2, 3, 4, 2 pi. With me? Yeah. Okay. Starting off, I'm going to do the y equals sine theta. What does that normally look like? Starts at 0. Make this a 1 and a negative 1. Sorry. I go up to 1, down there, down to negative 1, and then back to here. With me so far? Okay. Period of pi over 2. I'm going to do that whole entire thing by when? Pi over 2. So now I'm going to go ahead and do that whole entire thing by pi over 2. So here's pi over 2 right here, right? I'm going to go up, down, all the way down, and back to there by pi over 2. With me so far? Okay, what's that last set of instructions tell me to do? Phase shift, negative pi over 4. Left, pi over 4. So I'm going to move this point. So this is pi over 2. Each one of these blocks represents a quarter pi. So I'm going to move the graph over to this spot here. Here's negative pi over 2. Move to this spot right here. This spot right here. And I'm going to do this. I'm going to move this point to there, this point to there, this point to here, this point to here, right? Move everything, the whole thing pi over 4 to the left. Draw it in. And then finish out my graph paper. Okay? That's the way it's done. There's only 4 translations, and that's all 4 of them. Okay? All right? Is that making sense, sort of? If I send you home with homework, are you going to not do it because you feel like I'm just not going to try because it's too hard? Or are you going to try? You're going to try it anyway. We'll come back and we'll fix it. We'll practice some more next time. Does that make sense? Okay, so flip it over the back. Try to do what you can. Memorization quiz next time. It's the whole unit circle. I could ask any question. I could say sine of 7 pi over 6, and you got to give me what it is.
Are we going to fill out the circle?
No, I'm just going to give you a random. It's going to be a list like this.
But it's just
Of 10 things. It'll say sine, but if you know the unit circle, you want to draw your own, you're welcome to do so. I'm just going to say sine of 270, 200. I won't say 270 because you don't know that. Oh yeah, 270. Say sine of 270. I expect you to give me an answer. Yes.
So is it just that's like
Yes, it's only the ones you're supposed to have memorized, which is the unit circle. And again, if you remember the first quadrant, all sad tigers, caterpillars. If you remember that, those simple mnemonic devices, and then you know where to put the minuses, there's nothing I can do to you. You've got it all. Yes, ma'am. I would. Because in the future, I'm going to ask, what is the sine of 7 pi over 6? I don't want you to have to draw a unit circle every time you hit one of those. So if you do that, I'm not going to punish you. I won't be like, oh, come on, really? If that's the way you have to do it, that's the way you have to do it for this memorization test. But I would like you, the best scenario is you go, oh, that's just 30 degrees. 30 degrees is sine of 30 degrees 1/2. It's in the third quadrant. All sad tigers, that's tangent, so it's not tangent, so it's negative. Boom, done. That would be the best. Yes, if you want to draw a unit circle, I'm not going to stop you. I'm not going to say, slap your hand and say, no, you can't do that. Okay, but I won't give you one. So some of you learned some 1, 2, 3 thing trick, and that might just be too easy. Here's the 1, 2, 3 trick. You seen that? Oh, it's beautiful. For those of you who have terrible thing memorizing,